Hello dear students, welcome to YourPedia. Today I am going to discuss one of the interview questions that was asked previously in Baba Atomic Research Center interview for one of the students, okay, from power systems. That is, what is the difference between three-phase fault, LLL and LLG fault? Yeah. Immediately students will say that yes sir, in LLL fault all three phases are shorted, but in LLG fault all three phases are shorted and that is connected to ground also. But let's see, let's understand. See, this question is having a lot of discussion. Okay, it looks like very simple question. LLL and LLG, very simple difference. Let's understand the difference. Let me draw the circuit first. Let me draw the circuit. Yes. Yeah. Come here. So this is a three-phase source. This is a three-phase source, star connected source I am taking. Yes, generator in fact. And we all know that we are doing fault analysis on a no loaded generator only, because yeah, if you say that see, they will ask you to draw this, draw and explain. You started drawing this, you are taking a star connected generator. They will ask you why you are taking star connected generator, why not delta connected generator. Yeah, by taking delta connected generator also we can explain, there is no problem. Okay, and sir, neutral will be connected to ground. Neutral will be connected to ground. Yes, this neutral of the generator we are connecting to ground. So what is the purpose of connecting neutral to ground? Yes, we already seen, if there is no neutral grounding when LG fault occurs, arcing grounds phenomena is going to occur. They will ask you, see, interviews like BARC and this DRDO, ISRO will be mostly it will be like one question they will start, after that many questions, extension and cross questions. Okay, yeah, and yes, let me refine the diagram once. Yeah, now this is EA, internally induced EMF, plus minus, minus plus and minus plus. Yes, this is EA, this is EB, this is EC, is EA, EB, EC. Yes, and yeah, first let's take a LLL fault. First let's take LLL fault. All three phases, phase A, phase B and phase C are dead short circuited. Yes, so you have to draw this line, thick line, you know, you have to draw. Why? Because the fault current will be very high. To show that it is a fault, we have to draw a thick line. Fault current, to accommodate that amount of fault current, we have to show the thickness. Okay, so this is technical. We are engineers. We must represent everything technically in the diagram, right? Now, what is the fault current? See, this fault current is IA. This from this one IB, from this one IC. Anyhow, every wire is going to have some impedance ZA. Simply, I'll take this impedance as ZA, though I am not representing with help of symbol, just I am writing that ZA. This is going to have ZB and this is going to have ZC. For time being, take ZA is equal to ZB is equal to ZC is equal to Z. Okay, Z. This is equal to Z. This is equal to Z. Now, what is IA? IA is equal to EA by Z. And IB is equal to, yes, EB by Z. IC is equal to EC by Z. EC by Z. Now, if you observe, IA, IB, IC are balanced currents. If the voltage source is balanced, then definitely, and we taken ZA, ZB, ZC as equal, then definitely this system is a balanced system. Three-phase fault is a balanced fault. This is a LLL fault. LLL fault, and IA plus IB plus IC. See, this is the node. This is the node. This is the node. All three nodes are connected. So, how much is IA plus IB plus IC equal to 0? Why? Because it is balanced. IA plus IB plus IC is equal to 0. What this is balanced system. And why it is balanced? Source is balanced and these wires are having same impedance. LLL fault, all three phases are solidly shorted. Okay, solid fault it is called as. Now let me take a LLG fault. Let me take LLG fault. Yes, let me take a LLG fault. Yeah, just let me take LLG fault. Let me draw the diagram once again. This is EA, this is EB, this is EC. Yes, minus plus, plus minus, minus plus, and this is the neutral. Yes, neutral of the A, this is B, and this is C. Yes, neutral of the generator is connected to ground. I'm showing here solid grounding. I'm showing here solid grounding. There are different grounding methods. First of all, one has to understand what is the difference between earthing grounding. Okay, see, if you are connecting neutral of a generator to the ground, that process is called as grounding, neutral grounding. Earthing is for safety of the equipment. Suppose there is an iron box. Sometimes there is a possibility for the phase of the wire to touch the, I can say, a body of the iron box to be which you are holding. Therefore, there is a hazard for you. Therefore, what we do is that body, entire body of the iron box, we take a wire, and that wire is connected to earth pin at our home. That earth pin is connected to ground. Whenever you touch that iron box, and suppose if a phase is touching that body, that phase is finding two paths. One is through the body of the iron box to the earth pin, which is offering low resistance. Another one is through your body. If that earth pin is providing low resistance, fault current will flow through that and nothing will happen to you. If that is not there, we will get shock. That is earthing. Safety purpose for the equipment, what we are doing, that is called as earthing. For generators, especially three-phase synchronous generators and motors, neutral we are connected to ground. This process is called as neutral grounding. Okay, now which fault I am taking? LLG fault. Yes, LLG fault. Yes, I am showing here. Or fault will show like this. Okay, fault should be shown like this. I'll show it to you. Fault. Yeah. Yes, this is the fault, but it is connected to ground. Yes, with more thickness. Let me take. Yeah. Now if you observe, this is IA, this is EA, and this is ZA, that is equal to Z. This is EB, this is ZB, that is equal to Z. This is EC, and this is ZC, that is equal to Z. Now this is giving IA, this is giving IB, this is giving IC. Now you tell me how much is the current that is flowing. Let me draw clearly. Let me draw clearly here. See, I have to explain here. Yes, observe carefully. Observe carefully. One of the famous questions this is in interviews. What is the difference between those two faults? Most of the times this question can be asked. Good question, in fact, this is. Yes. Yeah. Now, if you observe, yeah, this is grounding. This is the, yes. Now, observe what should be the current that has to flow in this. This is IA. And this is IB, we already taken, this is IC. What is this current? IA plus IB plus IC, but three phase. See, this IA, IB plus IA. What is IA? First of all, tell me what is IA. IA is equal to EA by Z. IB is equal to EB by Z. IC is equal to EC by Z. So, EA, EB, EC are balanced system of voltages. Load is also balanced. Then currents are also balanced. Then how much is this one? 0 amperes. The current that is flowing through the ground in LLG fault is 0. Is there any significance of this all three phases connected to ground in LLG fault electrically? There is no. Electrically, LLL and LLG faults both are same. Electrically, there is no difference between LLL and LLG faults. Why? Because there is no current flowing to the ground in LLG fault. Why? Because it is a balanced fault. There is no electrical difference between LLL and LLG fault. Both are treated as same. Both are treated as same. Physically, there is a difference, that is here all three phases are not connected to ground. Those are connected but not connected to ground. Here all three phases are connected together and are connected to ground. Yes, this is the difference between LLL and LLG faults. It's a beautiful concept. Thank you.